What I wanted to do today was to go through a tutorial on using Python and a library called Trio to make network programs. And in particular, what we're going to build here is a simple TCP chat program. So this tutorial is going to be fairly rough and ready because what I intend to do is actually sort of develop the code live to help you understand how I go about writing the code for something like this. So to start with, what is Trio? Well, Trio is a library that allows you to do asynchronous code in Python. So there are multiple ways to do asynchronous code in Python, but Trio is my preferred one. The reason I like Trio is because it lets you write code in a way that makes a really good logical sense. It lets you catch errors and also properly raises exceptions for you when you make a mistake so that you can understand and not miss some really subtle bugs that you might hit in other asynchronous code. So, the simple chat program that I intend to write, basically each user has a long-running TCP connection to the server, and what we'll be writing is the server. When the user connects, they ask for their name. The users can send messages, and when a user sends a message, each other connected user receives a copy of that message. So I've made a folder here. There's nothing in it at the moment. So let's get started. So here is my folder in Visual Studio Code. So let's make a new file and call it server.py. Now what I'm going to use is I'm going to use a tool called pyenv to make a new virtual environment. Version 3.9.5 I believe I have installed, and let's call it Trio Tutorial. I'm going to activate that virtual environment. And now if I execute Python here, I'll be on version 3.9.5 and I'll be in my virtual environment. So if I do pip list, you won't have any libraries installed. Okay, so first of all, we need to install Trio. So let's pip install Trio. And over here, what I'm going to do is I'm going to choose in the Python extension here, I'm going to choose to use my new Python virtual environment. So I may need to refresh it up here. And then let's look here for our Trio tutorial. Okay, and so we'll be using now the correct virtual environment in my developer. So let's import Trio. Now the way Trio works is that you have to execute a trio.run, and this is to start your asynchronous function. So an asynchronous function is able to be suspended or frozen while other work is happening, while it's waiting on something to happen. So we can define our asynchronous function here by saying async def. So this is similar to a normal Python function. But instead of just saying def and the function name, we say async def. So I'm going to call my function main, and to start with, I'll just say print hi there. And so what we want to do is when we start this Python script, I'm going to say if _name is equal to _main. So basically, we only execute this code when this script is executed as the primary program. And I'm going to say trio.run, and then we're going to say main. So execute my main function here. And actually, maybe let's call it startup. That's a bit more obvious what it's actually doing. So startup. Okay, so let's see if this is working for us. So over here, let's say Python server.py. Cool. And so it executes. It defines the function, doesn't do anything there. Then it comes here, trio.run, executes startup, and prints hi there. Currently, we're not doing anything very interesting here, but we've got a basic skeleton. Next, what we're going to work on is opening some TCP listeners. So I've got some code here. So this is the documentation for TCP listeners. So there's in the Trio documentation, we have a whole bunch of stuff about sockets and networking here. So we've got open TCP stream. This is to connect to a TCP port and start talking to it. Serve TCP, so this will serve TCP connections, and for each one, it'll start a task running the handler that you provide for it. So this is the one we really want to do. We want to serve TCP connections. So let's use that. Now we need to actually define a function that we call when someone connects. So let's say async def connection. And what we're given here is we're given the stream to connect to. Stream. So what I'm going to do currently is literally just print the stream that we're passed in. And so now when we start up, starting up. So we'll print and then let's say await trio dot serve TCP. Okay, so we want to give it the handler, so connection. We can choose a port, so let's choose 9876. The reason I'm choosing that is it's a high numbered port and we can use it without admin permissions. Then there's a few other arguments we can use here, host, backlog, handler nursery. I'm not going to use those at the moment. We don't need to provide them, but this should be enough. So what we're doing is we'll start serving this TCP connection, and then every time someone connects, we'll call this function, and currently we're just going to print the stream. So let's give it a shot. I'll save that and we'll execute it. So it says, hi there, I'm starting up. Now to connect to it, we actually need to now connect. I'm going to use a tool called netcat. So netcat on the command line is just nc. It's got some help here about how to connect. Unfortunately, my terminal is so small that it's really hard to see what's going on. So if I maximize that briefly, we can see OpenBSD netcat, and you provide it various different arguments, but you need to provide it a destination and a port. We just want to use TCP, which is the default. So let's call nc localhost, so we're connecting to our own computer, 9876. Same port as we've got over there. And you can see that when we hit enter, we print out this trio socket stream object. So we've called this function and it's printed out the stream. Now what I'm going to do is show you that we can connect on a second terminal here, and you see it's printed out a new socket stream object. It's actually a different socket stream object. So what do we actually want to do when someone connects? Well, first thing we probably want to do is to ask them what their name is. So with our stream, we have a few functions available on that stream. So what it is a trio.socket stream. So if we go to this IO, we can actually look at the documentation for trio.socket stream. And that's under this generic stream tools. What we end up with is a socket stream. Okay, I've skipped to finding the socket stream in the documentation. So we have this trio.socket stream, and it has all these functions available on it. So we've got receive sum, send all, send EOF, etc. So what do we want to do here? Well, probably we want to first of all send something to the client who's connected. So looking back here, we want to say stream.sendAll, and we'll say, hi, what is your name? And I'll put a new line in there as well. So when someone connects, we're going to send, hi, what is your name? Now I'm going to save that, and I'm going to close and restart the server. So let's do that. And now I'll rerun one of these. Okay, what did we get? An error. Warning. Runtime warning. Coroutine send socket stream.sendAll was never awaited. And so what I've done is I've actually made a mistake here where I didn't await stream.sendAll. So when we send data on this stream, we want to await it. Because this network might be slow, so while it's sending these bytes, we just need to wait and free up the execution for someone else to send messages or receive messages. So I'll save that with await stream.sendAll, and let's kill and restart that again. And now, okay, so we got a new error. This time, type error, memory view. A bytes-like object is required, not a string, str. So I probably just need to make that a byte string by putting a B in front. Okay, and now let's try again. Okay, so we have progress. We now get a connection down here, and the server says to us, hi there, what is your name? Or hi, what is your name? Okay, so now the other side, the user is going to actually respond to us here. So what we want to actually do is receive the user's data until the user has provided us their username. So what we want to do here is actually await receiving some. So we can call this function, and it will return to us some data that has been received. So what we can do here is say current data equals empty byte string. So currently we have no data. And what I'm going to do is say while byte string \n not in current data plus equals stream dot receive some. And actually what I need to say is await as well, because we want to wait for the stream to send us some data. Now you might be wondering, why didn't I just say username equals await stream dot receive some? So why didn't I just say that? Let's get the username from the user. Well, the trouble is that in the same way that sometimes we can send data quite slowly, sometimes we will also receive data slowly. And particularly because of the way the operating system works, it may actually feed us data just in small slices. So even though I type Tucky here and hit enter, the operating system might only give us like 4 characters or 5 characters and not the whole block of data immediately. So what we need to do is sort of slowly build up the data, and what we're looking for is this \n, the new line character in the data, to know when we've received the full line. Okay, so current data plus equals await stream receive some. So while the new line's not in the current data, and then once the new line is in the current data, we will continue on to this point. And what we can do is we can say username equals current data dot split. So we want to split it. We want to split it by the new line, and we only want to split it a maximum of 1 time. So username, comma, current data equals. So what I'm going to do is I'm going to take the current data, and I'm going to split it by the new line, and I'm going to put the first section before the new line in the username, and then the second section I'm going to put in the current data, so that way we'll end up with the current data containing whatever is left. Okay, so now let's print hi there, and let's put in the username. Now, because this username is actually going to be bytes, we probably would want to actually decode the bytes into a string. But for now, I'm just going to print the username as is. Let's give it a shot. So, saved, executed, and now let's connect. What did we get? Current data.split. Okay, I need to split it by a byte string because it is a byte string, obviously. So, let's run that again. J. Okay, so I've just realized that we actually made a mistake here. We said, hi there, but we actually printed that. We didn't actually respond to the user here. So instead, let's not do print, but let's say await stream.send all. Can we do a formatted byte string? Nope, doesn't look like it. Okay, so what we're going to do is instead say this should work. Something like that. Let's give that a shot. Bytes object has no attribute format. So what I'm trying to do is basically put hi there and then add the username in. So maybe I should actually say plus with the byte string with the username that we've got. I'm trying to remember exactly how to do this. Okay, so it worked. We got hi there back, but we didn't actually get back the name. We didn't actually get back what we expected. We expected our username to be in the response. So let us here put in a breakpoint. So breakpoints are super useful for debugging. And I might put one just before this as well. So we'll put a breakpoint here and we'll put a breakpoint here. I'm also going to take out this print line. We know that we're getting a stream now. So let's have a look. So I start up, and what will happen is we'll execute all the way up to this breakpoint when something happens. So first of all, we connect. We're not in the breakpoint yet, but if I say JAY and hit enter, and then hit enter again, okay, now we've hit the first breakpoint. So you can see that it's at line 14 in the connection function, and the next line that it will execute is this. So that's the next line. The breakpoint is here, and then it's going to execute that. So let's have a look. We can say pp to pretty print in the debugger. Let's have a look at what current data is. Okay, so we've actually got current data just is an empty byte string. It's got the new line, but it has no actual no data in it. So here's my problem. If you recall when I was showing you why don't we just do that, that's actually eating all the data. So let's try this again with that corrected loop. So I'm going to quit that. And I'll leave the breakpoint in for now, but let's execute. And here I'll go. J, enter. Okay, and so now we've hit the breakpoint. So let's pretty print the current data. Cool. So now we have in the data J and then a \n. So we want to next execute this split. So if I hit C in the debugger, we can continue and then we'll stop at the next breakpoint. Okay, so we've now got to this breakpoint, and the next command will be to await stream.sendAll. So let's pretty print locals. So this will print all the local variables, and you can see current data is nothing. Stream is there, that's the socket stream, and the username is the byte string J. Okay, so let's just hit C to continue again, and now you can see it responds to us. Hi there, J. And it actually disconnects us now. And the reason it disconnects us is because this function has now finished. And so once the function finishes, the stream, the socket stream, gets cleaned up. Okie dokie. So now let's get rid of these breakpoints. We don't need those anymore. What we have done is, so now the user connects, we ask what the name is, we get the name, and we store it in the username. And then we say, hi there, username. And now let's start the chat loop. So what we want to do is basically loop forever. So while true, we want to wait to see if the user sends us data. And we also want to send data to the user if there is a new message from some other user. So currently we don't have the concept of multiple users really going on. So let's just, in the loop, await the current data. So what I'm going to do is copy this guy over here. So while there's no new line in the current data, so new line will be the indicator that a message has been completed. We will receive some data. Then message, comma, current data equals current data dot split, and let's do that byte string \n up to a maximum of 1 times. So what we're going to do is we're going to receive some data until we get a new line in the data. Then we're going to split it, and we'll use the message here, and we'll keep the current data, but with the message removed. And then process the message. So now we need to do something with it. As a placeholder, I'm just going to print the message for now. And we can sort of confirm that this loop is working. So let's kill and restart here. Just hit Q a few times to get rid of it. Okay, so run our Python server. Connect up. Hi there, what is your name? Jay. Hi there, Jay. And then I can say hello. And you can see that the message has been received by the server. What's happening? Is anyone there? And you can see that the messages are being sent. It's receiving them up here, although there is no actual conversation happening here. But this is good. We're getting closer. One thing I did notice is that when we respond to the user, we actually leave them on the same line. So let's chuck a quick extra new line here, plus \n. So that'll at least just put a new line on the end of that one. Okay, we have made some really good progress. So that's it for stage 1 of this program.